And welcome to the Data Journey YouTube channel. In this video I'm going to show you how you can work with polars with NVIDIA GPUs to speed up your data frame pipelines enormously. So if you don't know, polars is an alternative Python package that works with data frames. I'm going to the official page of the library so that you can see a bit what it is. So Polars is basically a library that states that it can work with data frames for the new era. This means that Polars is faster than Pandas and can also deal with a larger amount of rows without breaking your memory. Polars is written in Rust and it supports multi-thread by default. This means that calculations are sped up in your system, but also that multiple cores can do the work instead of a single one by default. So the library leverages that by default in all its operations. You'll see how amazing this is, particularly when we leverage GPUs, and in this case the NVIDIA GPUs that we will test here. So I'll give you this demo that I have here, the Polars GPU engine demo, that you can work around and play with using Google Colab. It's free and you can use it immediately. So here we can install Polars GPU and you can use the extra index URL to get the release version from NVIDIA so that you can use the GPU capabilities. To use the GPU capabilities, also make sure to go to the Google Drive properties here and then check the execution type that you have so that you enable a T4 GPU to be used. Okay, so this is very important because in that way you can use or leverage within this collab session. I already had this library installed, so it was pretty fast. Every time you open this notebook from scratch, you need to execute this. So what I'm going to work with here is this simulated transactions file that I'm going to go right now, which is a very large data set available in Kaggle. It contains almost 22 gigabytes of data. The original file contains, I think, 500 million rows. So it has a lot of data from transactions, financial transactions, where certain customers have bought something in a specific type of the day, an hour, and we have here the amount spent on that type of category. For example, motor travel, housing, entertainment. It's a very large data set and a common one that we find with financial transactions. So as I don't want to break my Google system and I want you to be able to run this code without spending any money on Colab, I'm using or downloading this version that contains 20% of the size of the dataset. Okay, it's a smaller version, but it's still large all the same. So we are going to download this Parquet file by running here and waiting a bit for this to download. After our Parquet file finishes, we'll have it available for us in our environment. Now, let's start to work with polars. So, as pandas as PD, polars as PL. It's the alias that we can use to work with polars. Just run this one. And now let's load our transactions Parquet file into a polars data frame. There you go, we have it here, and we can access collect schema to get column names and also the data types associated with this data frame. Okay, as we can see, we have basically cust ID as a string, start date as a date, end date as a date, and so on. So these are the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns that we have in our data frame, and we can also run the head command here on this data frame. The collect is a way for us to get the output. So let's run this one and see that this is exactly the same type of data that we have. If we go here, it's exactly the same row, the 20.27, the first row, it's exactly the same here on our data frame. Although, recall, we are using only 20%, it's not random. It's something that we are extracting the first 20% using that command. Okay. So the first operation that we will do, which is a very simple one, is just to sum the entire amounts on these data frames. So this is a very common operation that we can do with any pandas data frame. I've tried to run this code using pandas and I couldn't even load it into memory. So the way that pandas and polars work are completely different. This is not saying that you should replace all your pandas pipeline by polars. Just know that for large data sets, it may be a very good alternative to Spark, for example, and it uses kind of the same API and way of pandas. So it's easier to transition from pandas to polars if you would like. So I have here in this notebook all the time instructions that we have. And if I go here, for example, for transactions, I would also like to check the shape of this data frame. I need to collect and then do shape, okay, because this is a lazy data frame as it's not loaded into the environment immediately. I need to check collect. So I have right here around 52 million rows. So this is a lot of data, and probably pandas would struggle to deal with this amount of data, at least for these calculations. So let me go here and check how fast this calculation will be done, in this case using just the CPU. So I'm not leveraging GPU right now, I'm just using the CPU by default, and let's see how fast I can sum the amount of this table. So there you go. I'm going to consider the CPU time. Let's disregard the wall time. So CPU time is around 1.64 seconds to do this calculation. Pretty fast and pretty impressive. But let's see what will happen if we pass engine equals to GPU. This is absolutely amazing. 311 milliseconds to sum the amount of 50 something million rows. So this is awesome. If you had struggles on summing or dealing with large tables and large monetary values, this is just amazing, and it really amazed me when I saw these results. Polars is already pretty fast, but milliseconds to do this type of calculation is really mind-blowing. What I also like to say is that sometimes, and it may happen for you, the wall time will be larger in this operation, not because of the way that the calculation is being done, but because of the way you will generate the GPU engine, how the browser will load, and so on. What we can also do is to, for example, go here and just instantiate GPU engine as a standalone, basically lazy load this for later. And we can do it on this way. And now if you go here and run the exact same calculation, this amount, the sum of this amount, and passing our GPU engine inside, let's see, in this case, it's the same, 331 milliseconds. Now, of course, you may be thinking, okay, that may happen for more simple calculations, but what if we try more complicated stuff? For example, we would like to know which column or which customers have the largest total transactions. And our thought process would be sum the entire amount per customer and then sort that amount descendingly and select the top 5. So it's already a 3-step approach that in SQL we would spend some time to do. If we had our table pretty well indexed, this may be fast. In pandas it would take some kind of eternity to do. So let's try to do that here, and notice that the syntax and the API syntax of Polars is super similar to pandas, which is kind of cool. Now let's run this on the CPU. So this will take around some seconds, and let's see, probably some, I think, until 10. And we have wall time 726, but again, CPU time 4 seconds to run this calculation, which is quite impressive. But let's see when we pass the GPU what will happen. So running it, and 336 milliseconds. This is amazing. This is completely mind-blowing. Using Polars by leveraging the GPU engines is just completely amazing, and I'm totally blown away by these results. Now, one of the extra things, and to finish this video, is that we also have a SQL interface that we can use with Polars, which is quite cool. So if you are used to work with SQL, you prefer SQL syntax, and you don't want to use all the compound instructions of Polars and pandas, you can go here and just use the SQL syntax and run it, because the results will roughly be the same, as we will see CPU time for this type of operation, and on CPU and GPU will be pretty similar to our past experiments. So the SQL interface will not change that much the results, or at least the time it took to run. So this is super cool. I'm going to give you this notebook also that you can check in the link in the comments. Follow the Data Journey YouTube channel. I'll be releasing more videos about data science, analytics, and engineering, so that you can keep track of everything that's happening in this world, and also you can use these cool tricks for the future and for your career. So thank you for watching, and I'll see you in the next video.